Hello friends, welcome to this lecture of TOC. In my last lecture, I discussed what is a grammar, how important a grammar is for a TOC language, and we understood how we can derive a language from a given grammar. Now in this lecture, it is very important, we will understand that how we can how we can derive a grammar from a given language. Fine, as compared to the last lecture where I had discussed how we can derive a language from a given grammar. This time we will go in a reverse mode. That is, we would be provided a language, and from that language we have to derive a grammar. So how we can do that? Let us check that. Fine. So suppose we are provided a language for a grammar as an, and n is defined to be greater than 0. Fine. This is a language, and the question is derive grammar for this language or the above defined language. So how can basically derive the grammar? Let us check that. See, the first step that we have to do is that first simplify the above language. Fine. Simplify the above language. So if we simplify the above language, what we would obtain? We would obtain that, let us check that A0, A1, A2, and we would move so on. So this simply implies lambda as a fundamental string, A1 simply implies A square simply implies AA, which is nothing but A square, then A cube, and so on. Fine. So we have obtained a simplified version of the above language. Let us now check that how we can derive a grammar for this given language. So step number 2 is to derive grammar. So when we derive a grammar, always make sure to start the thing with the first string. Fine. We have to start with the first string. So we can simply take any variable. Let us say that we are considering a very basic symbol. Suppose we say that we have considered A. Fine. We have considered A as a start symbol. Fine. Or you can simply take S as a start symbol, as you wish. Fine. There is no problem. So in this case I am taking A as a start symbol. So the first string can be derived as A tends to lambda. Fine. A tends to lambda. So this is the first production idea. Now let us check the very basic idea that how I can define A, how I can derive A, and A in a successive manner. So what I can do, I can simply put A here, and using the previous production as A, I am in a position to define A. Fine, I am in a position to define A. So we can obtain this thing. And moreover, since you can see that this production is going to call itself again and again. Fine. This is you can say this is a recursive. This is a recursion. Fine. In a computer programming language, we basically discuss a recursion function where a function is going to call itself again and again. So here same thing happens. Fine. This A will call itself again and again to generate here lambda or A any number of times. Fine. And with the help of these two things we can generate the entire language. So we can say this is the required grammar. Fine. This is, we can say, required grammar. I can also write this grammar as by putting the A here. There is no problem. If I write this grammar as A tends to lambda and A tends to AA. I think there wouldn't be any problem. Fine, there wouldn't be any problem. So this is a simplified way of deriving the grammar for a given language. Fine, let us take one more example. So this time I'm changing the value as 1. So the first step would be step number 1. What I have to do here? So the first step would be that I have to choose a start symbol. Fine, I have to choose a start symbol. Suppose at this time I am choosing a start symbol as B. Fine, and sorry, the step number 1 is to simplify this thing. Fine, let us first simplify it. So algae would be A1, A2, A3, A4 and so on. Fine, as compared to the previous example, this time we don't have lambda as a first string. This time we have A here. Fine, so step number 2 is to choose the start symbol. Fine, so start symbol can be any non-terminal, that is uppercase character. So this time I am taking the start symbol as a B. Fine, and this B, let us first generate the very first string. Fine, very first string, that means B tends to A is our production. Now what we can do, we can simply, we want to derive the each thing successively. So what I can do that as I take the first production as a B tends to A, I can once again define B for the second time. Fine, but this time I will use how I can produce the successive things. Suppose A square, if I am able to derive this A square. So in order to derive a square, I can write simply A, and using the previous result, fine, and this previous result can be obtained as using B once again. Fine, so if I define B once again here, so we can see this B is going to recursively call itself to generate successive A's, and with the help of this production itself I can generate all other strings. So fine, it is a very easy way. So we are obtained with the required grammar. I can also write it as B tends to A, then B tends to BA. Very easy. Fine, it is a very easy. Now let us take the another example. Fine, more example from the standpoint. So this time what I am doing, I am putting value 4n plus 1. Fine, I am putting the value 4n plus 1, and this time I am taking 1, or if I take it as a 0. See what happens if I take it as a 0. So the step number 1, as I told you, you always define a simplified version of this language. So the simplified version of this language would be, number 1, substitute 0 here, we would obtain A. Substitute 1 here, we would obtain 5. Then substitute 2 here, we would obtain 9. Then substitute 3 here, we would obtain 13. Fine. So in this fashion we can obtain the successive language. So what I can do, step number 2, I have to choose a start symbol. You can choose any of the non-terminal as a start symbol. Suppose this time I am choosing S as a start symbol. Fine. So the first step is to define a production for the very first string. So what I can do, I can simply define S tends to A. Fine. Now let us check how we can generate the other successive string. If we observe carefully here, we would find that I am obtaining basically A4, A4 and so. Fine. If you simply just divide it, you will simply obtain that we obtain A4, A4, A4 on each successive step. There is a difference of A4, A4, A4 in each successive step. So what I can do that I can define this as recursively to generate A4 with the previous term. Fine. So what we can obtain that this A4 and this A will merge to define A5. Fine. For the first time it would be A5. Then when I once obtain this A5, what I can do once again, suppose S A4 S, it further go and it would define A4A, which we will obtain as A5. Then I can also take as a I can call it successively like A4 and again A4S. Fine. And from the previous step, this is a first, this is a second, this is first, this is second, this is second, and this is first. I would obtain A4, A4 and A, which is nothing, A9. Similarly, I can obtain A4S, A4, A4, A4S this time, and then A4, 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 A, which is nothing, A. Fine. This is the significance of the recursive call of the function, that we can obtain the similar type of the string successively. Fine. Fine. So this is how we can generate a grammar. Let us check another example. This time for the different language. This time for the different language. Suppose this time, if I have a language W which belongs to A star, and W, the length of W is mod 5 is 2. So what is the meaning of this? So step number 1 is to simplify this language. Fine. So how I can define this, as you can understand that this simply represent n. Fine. Mod of W means n, suppose, and we can understand this simply represent that I can have A0. Fine. This simply represent I can have A0. No, sorry, this means infinite. Fine. I can generate any possible of the string here, and we simply determine it as a n, length of n. Fine. I can determine it as a n. So what would be the n mod 5 is equal to 2 means? It means that if I divide this thing, if I take the mod of 5, I will obtain, it simply means n mod 5, that is a remainder. And what could be the remainder that I can obtain would be 0, 1, 2, 3, 4, 5. These are the various remainder that we can obtain after dividing a given number by 5. And here we are told that we have to obtain only remainder 2. So if we obtain only remainder 2, that means we would obtain the first string as A2, and then after every 6 in this A2 we have to add 5. We have to move 5 steps further. That means again A5. If I add A5, it would be A7. And you can see that if I divide 7 by 5, once again I would obtain the remainder 2. Then again, if I obtain A12, a difference of 5. Fine. If I add 5 again, I would obtain A12. And if I divide this 12 by 5, I would obtain once again 2 as a remainder. Right? So in this way, I can obtain this thing as a generalized language of our given language. So step number 2 is very simple. What we have to do? We have to do simply the production. We have to define a production. So very simple. We have to derive a production for the very first string, and then we can make the recursive call, fine, to obtain the above language. Right? I think you are now in the getting the what actually the way to derive a grammar from a given language. Fine. This is all from this lecture. We will discuss a more example on how we can generate grammar from the given language in our next lecture.